Welcome to Mrs. Miller's notes for her pre-calculus class. These are the notes for section 5.2, day 1, entitled Trigonometric Functions of Real Numbers. And today we're going to focus on the 6 trigonometric functions and how they relate to the unit circle. And then we're going to find the values of some trigonometric functions using our unit circle. Now remember that a function is a rule that assigns to each real number another real number. So when we have our trigonometric functions, they're just rules that are telling us how to evaluate a specific number. So we're going to use the properties of the unit circle to help us define those trigonometric functions. And the 6 trigonometric functions that you should be familiar with that you've used in the past are sine and cosine and tangent. Now when you were in geometry, you probably learned the little phrase SOHCAHTOA. And that was kind of a mnemonic device to help you remember what the ratio was for sine and cosine and tangent. So the sine of any given angle is going to be the same as the opposite over the hypotenuse. Now remember, in geometry, this was all related to right triangles. So you're trying to take the sine of an angle. And that angle, then, if you took the sine of that angle, would be the same as the ratio of 2 given sides in that triangle. In this case, the opposite side over the hypotenuse side of the triangle. Okay? And the cosine of any angle is the same as the adjacent side over the hypotenuse. And then tangent, it was TOA, so tangent is the T, opposite is the O, and adjacent is the A. And then in Algebra 2, you should have learned the inverses. So the inverse of sine is cosecant, or CSC. And then we have the opposite of cosine, which is secant. And then the inverse of tangent is cotangent. So to find their ratios then for cosecant, you basically are doing the reciprocal or the inverse of sine. So this is going to be hypotenuse over opposite. Or you could think of it as 1 over sine. Secant then will be hypotenuse over adjacent. Or you could think of it as 1 over cosine. And then cotangent is going to be adjacent over opposite, or 1 over tangent. Now there's another relationship for tangent and cotangent that we'll talk about in a little bit. But for now, this should be what you remember of your 6 trigonometric functions. Okay, now we know that to find the terminal point for a given number or a given distance, we move that distance around the unit circle from our starting point, which is 1, 0. And we go counterclockwise, or we go up if the direction is positive, and we go clockwise or down from that starting point if the direction is negative. So that's what we've talked about in all of section 1.5. That's still gonna, or I'm sorry, 5.1. That's still gonna be true in this section. So now we're going to use the x and y coordinates of the point to define some functions. So we're really going to focus on the terminal points now when we're dealing with these trig functions. Okay, so this is why those terminal points were so important, why we spent so much time in the last section figuring out what they were, because they can help us now evaluate sine and cosine and tangent of these measurements in our unit circle. So let's just say that in our first quadrant of our unit circle here, we have a 30-degree section that's been sliced out. Okay, so for a 30-degree section in the first quadrant of the unit circle, which trig function, either sine or cosine or tangent, would you use to get the x coordinate? of the terminal point. And the terminal point's listed right here. Square root 3, 2, and then square root 3 over 2, and then 1/2. Okay, so they want us to figure out if I did the sine or the cosine or the tangent of 30, which of those would get me square root 3 over 2? Okay, and then they also want us to know which function, sine or cosine or tangent, is going to give us the y coordinate, which would be 1/2. So let's just go through these one at a time then. If it's sine and cosine and tangent, let's just figure out what the sine, cosine, and tangent are for this measurement here. Okay, so we would be taking the sine of 30. Remember, sine is opposite over hypotenuse. So we've drawn in our little reference triangle here. And this is the measurements for our reference triangle based on a unit circle. Okay, normally the sides are 1, 2, and then square root 3. But in a unit circle, remember, the radius is 1. So we had to divide everything by 2 then. So we have 1 and 1/2 and square root 3 over 2. We talked about that in section 5.1 as well. Okay, so sine is going to be opposite. So remember, that's the side that's directly across. And then our hypotenuse. So it would be 1/2 over 1. Well, that's just 1/2. Well, the 1/2, hey, that's my y coordinate. So if I took the sine of 30 degrees, I get the y coordinate in that terminal point. Okay, let's do cosine. Cosine of 30 is going to be the adjacent side over the hypotenuse. Now the adjacent side is the side that's like right next to the angle. So that's square root 3 over 2 over 1. 1 is our hypotenuse. So that's just the square root of 3 over 2. And hey, that's our x value in the terminal point. So to find the x coordinate, I take cosine of that angle. And to find the y coordinate, I take the sine of that angle. Very interesting. Now, if I did tangent, that's not going to get us either of those values in the terminal point, so I'm not going to worry about tangent. So now let's see if this holds true for the other measurements in the first quadrant. So let's see if for a 45-degree section, if I take the sine of 45, do I get the y value? And if I take the cosine, do I get the x value? Well, if I do the sine of 45, I'm going to have opposite over hypotenuse. So that's square root 2 over 2 all over 1. So that's just square root 2 over 2. Okay, well that could be my y value. It could also be my x value because they're the same. And if I did cosine of 45, okay, cosine would be adjacent over hypotenuse. Well, those sides are still the same, the opposite and the hypotenuse and adjacent. So I do get square root 2 over 2. Okay, but again, since my x and y values are the same, it's hard to know which square root 2 over 2 I'm getting. So that observation might hold true for the 45-degree section. Let's really double check it though with the 60-degree section. Okay, so if I do the sine of 60 degrees, let's see, I'm going to have opposite over hypotenuse. So that's square root 3 over 2 over 1, so that's just the square root of 3 over 2. And hey, that's my y value in my terminal point. Okay, so that was the same as what we got for the 30-degree. And now if I do cosine of 60, that's adjacent over hypotenuse. So 1/2 over 1, that's just a half. Hey, that's my x value. All right, so it looks like that observation is going to hold true. So basically, anytime you're dealing with sine and cosine in your unit circle, the terminal point around the unit circle is actually cosine of that distance and then sine of that distance. So the x value in your terminal point is going to be the cosine of t, And the y value in your terminal point is going to be the sine of t. Remember, t can be that angle measurement or that distance, that radian distance. Okay. And then we have some notes here about, so every sine is going to be every y coordinate, and every cosine is going to be every x coordinate. We just said that. And then cosine, tangent, cosecant, and secant, and cotangent. Okay, so basically we can find all of the other values knowing sine and cosine. And here's how. Okay, sine is going to be all of the y values. Cosine is going to be all the x values in the ordered pair in that terminal point. And then tangent is going to be y over x. So tangent is really sine over cosine. Oops, that's cosine. Okay, so before, when we were talking about tangent, we referred to it as opposite over adjacent. That's if you're dealing with just a specific triangle. Okay, but now we need to remember that tangent can also be sine over cosine. And then cosecant is the inverse of sine, so that's going to be 1 over y. And then secant is the inverse of cosine, so it's going to be 1 over x. And then cotangent will be the inverse of tangent, so it's going to be y over x, x over y, or cosine over sine. So that's the other way that we want to remember tangent and cotangent now. So we really need to focus on tangent being sine over cosine. So these are how the 6 trigonometric functions relate to the unit circle. And sometimes they might be called the circular functions when we're talking about them in terms of a unit circle. So if you see that in the book or in directions in your homework, just know that that's what they're referring to. Okay, so remember, this is the terminal points for the first quadrant. So we have our starting point, we have our 30 degrees, 45 degrees, 60 degrees, and then our 90-degree measurement. Okay, and remember, these are going to be our reference angles as well. So if we can find out the location in the unit circle, find out which of these measurements it's referencing, then we can evaluate the sine, cosine, tangent, or cosecant, secant, or cotangent of that t value, and then just make the sign appropriate for whichever quadrant we need to be in. So that's what we're going to practice now in this example. It says to find the 6 trigonometric functions of each number. So, for example, 1 part A, we have t is pi over 3. So pi over 3, that's in our first quadrant. I need to know the terminal point for pi over 3. So I'm going to just make a note that that is 1/2 square root 3 over 2. Okay. So now I have to find the sine and the cosine and tangent, and then I'll do the inverses of them for cosecant, secant, and cotangent. Okay, so the sine of pi over 3, remember that's just going to be the y value, so that's square root 3 over 2. Cosine of pi over 3, that's our x value, so that's just 1/2. Easy peasy. Now tangent of pi over 3, we have to do a little work here. Remember that was sine over cosine, so that's going to be square root 3 over 2 over 1/2. And I have to simplify this. I can't just leave it as a fraction and a fraction. So I have to multiply by the reciprocal, so I'm going to have to multiply by 2 over 1. So that's going to cancel all the way down to the square root of 3. All right, and then cosecant, remember that is basically 1 over sine, or it's going to be the inverse of this, or the reciprocal of this. So you could think of it a couple different ways. You could do 1 over square root 3 over 2, but then you have to multiply by the reciprocal, so I have to multiply top and bottom by 2 over the square root of 3. So I get 2 over the square root of 3, which is the reciprocal of the sine value anyway. But then I still have to rationalize this, so I have to multiply by the square root of 3. So I get 2 square root 3 all over 3. And then secant, same thing. We can think of it as 1 over cosine. So cosine was a half. And then you have to multiply by the reciprocal, so I'm going to have to multiply by 2. So that's just 2. Okay? Or you could think of it as just taking the reciprocal of the cosine value. So the reciprocal is 2 over 1, 2. And then cotangent. Again, we could think of it as cosine over sine. So we could do 1/2 over square root 3 over 2. But then I have to multiply by the reciprocal, so I have to multiply by 2 over the square root of 3. So then I get 1 over the square root of 3. And that's the reciprocal of what I had here for my tangent value. So if I don't want to do all of this work, I can just look at my tangent value and then take the reciprocal of it. But I also have to rationalize this. I can't leave that radical in the denominator. So it's square root 3 over 3. Okay, so once you know the sine and the cosine values, you can really do some quick algebra to go through and find the other 4 values. Okay, so let's take a look at B now. We have pi over 2. Now pi over 2, remember that's 90 degrees, so we're going to be on our y-axis. So the terminal point there is going to be 0, 1. So if I'm trying to find the sine value, sine of pi over 2, that's just going to be my y value, so that's 1. Cosine of pi over 2, that's my x value, so that's 0. And then tangent of pi over 2, okay, that's sine over cosine, or 1 over 0. However, anything that you divide by 0 is undefined. So we don't have a value there for the tangent of pi over 2. Cosecant of pi over 2, that's going to be 1 over sine, which is going to be 1 over 1, which is just 1. Secant of pi over 2, that's going to be 1 over cosine, so that's 1 over 0. So again, that one's undefined. So it's okay if sometimes you get an undefined value. Not all trig functions on the unit circle have a value. And then we have our cotangent, which is going to be cosine over sine. So that's 0 over 1. So that's just 0. Okay. So here we see that sometimes we can get nice simple values like 1, or we can get the value of 0 for an answer. So don't be afraid if you get 0 for an answer. It's not wrong. Or we can have something that's undefined. So again, don't be afraid. Don't feel like you did the problem wrong if you get undefined. Now, in your book, on page 378, I believe, they have this lovely chart. And this chart basically gives you all 6 trig functions for the entire first quadrant. So you can memorize these if you'd like, or at the very least know how to work through them using the trig ratios in order to get these values. And that's what we did in the previous example. But these are values that we're going to use a lot. These are going to be answers that you're going to be getting a lot as we go through these problems. Okay? but make sure that you are familiar with these. And again, notice that these little dashes here means that there's undefined values. Okay, and some of our answers are 0, some of our answers are 1, some of them are 1/2, and then we have some radicals in there too. So like we said, some of our trig functions fail to be defined, and we also have to be conscientious of our domains for our trig functions. Okay, not all trig functions exist in every quadrant, and it's basically determined by what their denominator is. Anytime they have a denominator that's going to be 0, that's where they're going to be undefined. So cotangent and cosecant have a y in the denominator, so they're not going to be defined whenever that y coordinate of a terminal point is 0. Right? And then the functions of tangent and secant, they have x in the denominator, so they're not going to be defined whenever x is 0. So whenever that terminal point has an x value of 0, tangent and secant will be undefined for that quadrant. Okay? So you can, in this little chart here, they break down the domains for all of the trig functions. So sine and cosine, they're always going to be all real numbers. But tangent and secant are going to be limited whenever x is going to be 0. And cotangent and cosecant, they're going to be limited whenever y is 0. Okay, so now we're going to do a few examples where we're actually going to find the values of some trig functions. And to compute the other values of trig functions, we have to basically find their signs. And there's a couple different ways that you could do this. You could find the reference angle and then think about that value and then think about what quadrant you're in the unit circle. Or if you have the big picture of the entire unit circle, you can just find that angle and look at your terminal point and look at the value, x or y value that you need in your terminal point. Okay? But knowing where the trig functions are positive and negative can be a little bit of a shortcut to help you. Okay? So right down here, they say sine, cosine, cosecant, and secant are all negative, and then tangent and cotangent are going to be positive. I think there's a little chart that breaks that down as well. So in the first quadrant, all the trig functions are going to be positive. In the second quadrant, though, only sine and cosecant are going to be positive. In the third quadrant, tangent and cotangent are going to be positive because you have a negative divided by a negative. And in the fourth quadrant, only cosine and secant are going to be positive. Okay? So again, you can remember that. Okay? If you want to remember what values are going to be positive in which quadrants, that's fine. Or you can just work through the process and your positives and negatives will all cancel out or stay as they need to. So let's take a look at this example. This is our last example here. And we're going to find the value of these trigonometric functions for these radian measurements around our unit circle. So if you have your unit circle handy, or if you have memorized that first quadrant, okay, we're going to try and focus on using that first quadrant as our reference angles, like we've done in the previous sections of our homework. Okay, so first thing we want to do for part A here, if we're evaluating cosine of 2 pi over 3, is we want to figure out where 2 pi over 3 is. Okay, 2 pi over 3 is going to be in our second quadrant. It's right about there, 2 pi over 3. So our reference angle then is going to be pi over 3. That's how far we have to go to get to the x-axis. So remember, this terminal point is going to be the same as pi over 3 in the first quadrant. And it's cosine. So remember, in our ordered pair, we have cosine for the x and then sine for the y value. So we really want the x value of the ordered pair for pi over 3. So pi over 3, the terminal point for pi over 3 is going to be 1/2 square root of 3 over 2. Okay, that's our terminal point. And I want the cosine value, so I want the 1/2, but I'm in the second quadrant. So if I'm in the second quadrant, remember all of these x values in the second quadrant are going to be negative. So I want negative 1/2. Okay, for part B, now I have the tangent of a negative pi over 3. So that means I'm going to move down. So pi over 3 down here. Okay. Now again, my reference angle is still going to be pi over 3. So I have to think, again, what that terminal point is going to be for pi over 3. Well, that's what I had up above, too, for part A. So that's 1/2 and square root 3 over 2. Now remember, it's tangent, so I'm going to do sine over cosine. So the sine was the y, and the cosine was the x. So we're going to do square root 3 over 2 over 1/2. So I'm going to multiply by the reciprocal to get those double fractions out of there. So I end up with the square root of 3. Now I have to think of my signs for the fourth quadrant, okay? Because negative pi over 3 was in the fourth quadrant. So when you're in the fourth quadrant, you're positive, negative for your ordered pair. So the 1/2 would be positive, but the square root 3 over 2 would be negative. So I need that negative to carry through there. So I'm going to get negative pi over 3. Okay, for part C, now I have sine of 19 pi over 4. Now remember, in the previous sections of notes, we've talked about how you can take those big radian measurements and subtract 2 pi to get them down to their smallest amount. So I'm going to take 19 pi over 4, and I'm going to do that. I'm going to subtract 2 pi. Now remember, it's 2 over 1, so I have to find a common denominator. So if my denominator is 4, I'm really subtracting 8 pi over 4. So that'll be 11 pi over 4. That's still an improper fraction, so I'm going to subtract another 8 pi over 4. So then I get 3 pi over 4. Okay, so really I'm finding the sine of 3 pi over 4. That's really what I'm doing here. That's my terminal point. So if I went around the unit circle 2 times, that's what's happening here. I'm going around 1 time, going around another time, and then I end on 3 pi over 4. Okay, so 3 pi over 4, if I break that first semicircle, the first and second quadrant, if I break that into fourths, okay, I need 3 of them. 1, 2, 3 pi over 4 is going to be over here. I'm going to be in the second quadrant. So remember, in the second quadrant, your ordered pairs are negative, positive. Okay. So 3 pi over 4, remember this is where I'm going to have the square root 2's over 2's. Okay. So my ordered pair, my terminal points can be square root 2 over 2, and then square root 2 over 2. But since I'm in the second quadrant, that's first square root 2 over 2 is going to be negative. So I want the sine of that, so that means I want the y value in my ordered pair. So I just really want the positive square root 2 over 2. Okay, in part D, again, we have another negative value. We have negative pi over 3. And then we have secant. Okay, So instead of sine or cosine or tangent, now I have secant. And secant, remember, that's our inverse of cosine. Okay, so negative pi over 3. Let's see where that is. Okay, if I go down pi over 3, it's going to be right about here. So I'm in my fourth quadrant, so I'm going to be positive, negative. Now my reference angle is still going to be pi over 3. Okay, remember that ordered pair is going to have the same terminal point. That terminal point is going to have the same x and y values as pi over 3. It's just going to have different signs. Okay, so pi over 3 is going to be 1/2 and then square root 3 over 2. But if I'm in my fourth quadrant, okay, the first one's going to be positive, the second one's going to be negative for my x's and my y's. Okay, and then secant, that is going to be 1 over cosine. Okay, and my cosine value is the x value. So that's going to be 1 over 1/2, which is 2. Okay, so when you're thinking through this, there's not really necessarily like step-by-step concrete rules. It's a lot of thinking through the process, but it is good to, draw where you are on the unit circle. Think about your signage here we were in the second quadrant, so we were negative, positive, okay? Think about what that terminal point is going to be for your reference angle, and then use your ratios for your trig functions to help you work through and evaluate the appropriate value. Okay, so you definitely want to practice this. Okay, the answers to the odds are in the back of the book, so as you work through them, check them, make sure you get them right. It's very easy with these types of problems to miss one little thing and throw off your problem. Okay, so definitely check your work. Remember, I have the binder with all the solutions worked out in the classroom, so you can check that. Otherwise, come by and see me before school.